Hi, I want to talk about how to draw structures from formulas that we get for chemical compounds. You're familiar with formulas. They're like letters and numbers. So CH4 means 1 carbon, 4 hydrogens. And CBr4 means 1 carbon, 4 bromines. And H2O, O2, N2, C3H8, and C2H2 are all formulas that we've seen before. In order to draw the structures, we have to really understand how many valence electrons each element has. And so we can look that up by looking at the periodic table. So we got carbon. We know carbon is in group 14, so it's got 4, and hydrogen's in group 1, so it has 1. So we've done this before, and that's what I've done. I've drawn in the valence electrons. What we then need to do is we then need to put one in the middle, and it's probably the carbon. And then we arrange the 4 hydrogens around it, and we add in the electron that it shares with the carbon. So each hydrogen brought 1, the carbon brought 4, so there's a total of 8 electrons around the carbon. That's our goal. We want to have 8 around the carbon and 2 around each hydrogen. Now, we don't normally draw structures like that. What we do is we put in a little line to represent a pair of dots. So C, H, 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 H. So each little line represents a pair of electrons. Now, carbon tetrabromide works pretty much the same way. What we have is we put the carbon in the middle, and we put its 4 electrons around it. And then the bromine has 7 electrons. So its 1 lone electron fits over here, pairs up with the carbon and bromine. And since there's 4 of them, we arrange them around the bromine atom. Now we take a look, we see there's 8 carbons around, 8 electrons around the carbon, 1, 2, 3, 4, 5, 6, 7, 8, and there's 8 electrons around each bromine, 1, 2, 3, 4, 5, 6, 7, 8, all the way around, 2 on each side. And again, we would draw its structure using lines to represent a pair of electrons. And notice how we don't draw the electrons around the outside, because we know there's going to be 8 electrons around the bromine. And each line represents a pair of electrons for the carbon, so there are 8 electrons around the carbon. Let's take a look at water. Oxygen is in group 16, so it's got 6 electrons around it. And hydrogen has 1 electron. Well, I think we can see where that fits in. And so we have the O here, and it's 2 electrons. H shares this 1 electron with that 1 from oxygen, and we get water. And then we would simply draw that as O, H, H. We always draw water bent like this because those 2 electrons up there take up space, and they push those hydrogens down, so it makes it a bent molecule. Oxygen and another oxygen for O2. Now we can see how these electrons will pair up here. So but we still have these single ones down here on the bottom. So what happens is that if we just draw them in like this, we see that each oxygen has 1, 2, 3, 4, 5 around it. I'll take that back. Here we go. There we go. This one has 1, 2, 3, 4, 5, 6, 7 around it. And this one has 1, 2, 3, 4, 5, 6, 7 around it too. But it needs 8. But you see these two lone guys here? What happens is they move in, and we have now 4 electrons being shared with the oxygen. So now there's 1, 2, 3, 4 in between, plus 4 over here means I got 8, and these 4 in the middle plus these 2 make a total of 8 as well. Now since there's 2 pairs of electrons being shared, we represent that as a double line. Take a look at nitrogen. Nitrogen, we know, has 5. So if we put them together, we get nitrogen, we still have unpaired electrons here, so we've got to kind of move them in between. So if we move these 2 guys in here and these 2 guys in here, we're going to have a total of 6 in between the 2 nitrogens. And there will be 2 that are still paired. And now we can check around here. We've got 1, 2, 3, 4, 5, 6 nitrogens, plus 2 makes 8, and these 6 plus these 2 make 8. Every nitrogen is touching 8 electrons, so it's happy. Now each pair represents a line, and so since I have 6 electrons in between, I'm going to draw a triple bond between the nitrogens. We can also make bigger molecules. So our carbons here, we got 3 of them, and usually carbons make a chain. They're all connected to one another. And then I have 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. And between each of them, there's a carbon. Carbon shares an electron, and hydrogen donates an electron. So we get 2 from each of them. And we see that all the carbons have 8. All the hydrogens have 2. So we call this ethane. And we can draw it using sticks. Oh, pardon, that's propane. This is propane we're drawing here. We'll do ethane later. Now, so that would be propane. Now let's try this one. I've got 2 carbons. Now they're going to be attached to each other. And then they have 3 more electrons for sharing. And then hydrogen fits in here and donates its electron right there. However, each carbon only has 1, 2, 3, 4, 5, 6 around it. So I need to share 2 more. However, I've got these unpaired electrons out here. And what happens is that they'll move inward and get between the 2 carbons. So now we have see how these 4 electrons move down here, 1, 2, 3, 4, to join these 2 in the middle. Now I've got 3 pairs of electrons, so that means I've got a triple bond. And so if I draw the stick picture, it'll look like this. And this is what we call acetylene. It's for welding. Burns very hot. It'll melt steel. It burns so hot, it'll burn underwater. So, that's how we draw structures from formulas. Next video, I'll show you how we make shapes out of those structures.